Hi, welcome to our first Harvard Data Science Initiative Industry Seminar of the academic year. I'm Jen Chow, I'm Director of External Engagement, and I'm pleased to introduce today's speaker, Michael Curran from Instacart. Michael is Director of Platform and Foundations Data Science at Instacart, where he supports and leads data science teams focused on experimental design, Carrot AI, fraud, pricing, and payments. His career highlights include many household names in the tech sector, including TikTok, Pinterest, Netflix, and Facebook. He studied at Fordham University, the University of Florida, University of Michigan, and received his PhD in 2008 from the University of Arizona. Before I hand over to Michael, I'd like to remind our audience that there will be time after his presentation for questions. Audience members should use the Q&A function to send in their questions at any point during the presentation. Please don't be shy. All questions are good questions. All right. Well, thank you and welcome, Michael.
Amazing. Thank you, Jennifer. It's great to be here with everybody, and thank you so much for inviting me to be the first speaker of 2024's fall series. Really appreciate it. I'm Michael Curran. I am a data science director at Instacart, as Jennifer mentioned, and I'm here to tell you about some things that, over the course of my career have struck me as interesting about experimentation in industry, and generally highlight how many of the things that I found interesting began and originated in academic work, but probably isn't stuff that academics are regularly focused on today. And so it's a little bit of an interesting kind of like epistemological origin that many of these projects that I'll tell you about have begun with. Let's see. My sense of this presentation is that I'll generally keep things pretty high level. There definitely are deep dives that could be happening for any of the topics that I'll talk about. That said, happy to talk after the presentation as well, and generally, follow up on anything that's of interest to folks. I'll share my screen now, and one thing I'll see if I can broadcast this at full. Perfect. One thing that I'll ask is if folks have interest in anything that I'm about to talk about, or even if it's just simply about what it's like to do data science in industry, please jot down my email address and hit me up. I'm happy to have any conversation with anyone, students, professors, what have you. Really, the collaboration between industry and academia isn't strong enough as it could be, at least. And so anything that we can do to, whether it's talking about things like jobs or whether it's talking about partnerships in terms of writing papers, all of this is stuff that I'd love to hear from you about. So I put my email address down here. It's also at the end of the whole thing. So if you can grab a pen, if you're interested, feel free. Okay. The agenda for today's session, I will put together some introductions. I want to introduce a little bit about my experience, but also in particular, a little bit about Instacart to give you a sense of where I'm coming from and just generally what the business is and the kinds of questions that tend to pop up as relevant for data scientists who are employed there. I'll go over our State of the Union, things that are the kinds of experiments that we run at the company, the general context behind what it is that we are, what it is that we're doing, and how people think about experimentation. And then I'll explain 3 challenges that we've recently tackled in the last year or so, and take you through kind of what our solutions were to those problems. And that'll give you, I think, a little bit of a sense of what I mentioned earlier about how the industry challenges are perhaps a little bit different than academic, but still rooted in the same fundamentals. So stay tuned for that. And then I'll tell you about things that we're thinking about in terms of the next 12 months. So that should be. I'd love to solicit opinions about what folks think might be solutions to some of these questions that are top of mind when it comes to our future work. And then we'll do a Q&A at the end, moderated by Jennifer. And so hopefully that will be interesting and exciting. Great. So for folks who are not familiar with Instacart, this is an app where users can, what we refer to as, build a cart, primarily for online delivery of groceries. And what that entails is really what we refer to as a 4-sided marketplace. And the four sides of the marketplace are really where all the interesting questions come from when it comes to the business and when it comes to data science, really, and the kinds of things that we're trying to figure out. The four sides of the marketplace are: first, you have a core experience team, and that's pretty obvious, focused on what are the users on the platform, what are they doing, what are they experiencing as they scroll through the app, how can we make that as seamless and as delightful as possible. Then you have an ads team, where inside the app, we're actually showing ads, very similar in scope to what Amazon does in terms of sponsored products, where we're promoting some item for your groceries that are fundamentally related to what it is that you've searched for or you've browsed for, but nonetheless is being promoted by a consumer packaged goods company. And in turn, we are looking, that team is looking to generate as much ads revenue as possible as part of the platform. And you can imagine there's a little bit of a friction between what's best for the user and what generates the most ads revenue. And so that's just two sides of this four-sided marketplace. But again, interesting trade-offs will emerge. The third side is the shopper side. And so once an order has been placed, we have to determine who is going to actually select and pick the items in the store, how they're going to get through the store as fast as possible. In most cases, the picker, the shopper, has not actually been to that store beforehand, so they need a map of where to go. You could spend hours hunting for 25 or so items in a store if you've never been there, or you could spend minutes. And so the goal of this team is to facilitate the efficiency of that picking process. Once the whole thing has been picked, there's then the step of getting that to the groceries to your actual home and do the delivery. And again, that brings about similar kinds of questions that you would see in terms of like Uber, Lyft, Google Maps, even trying to direct folks the fastest way possible to between the store and the person's home. And then finally, we have a retailer team. And the retailer team is looking to basically understand, what is the value of having Instacart as a partner and thus having online grocery facilitated for their store or for their set of stores through this app? Why not do it by ourselves? What's the overlap between stores, shoppers who buy groceries in store versus shoppers who are buying on the app? And so the extent to which that team exists is to largely prove the value of Instacart as something to that retailers ought to partner with and continue to invest in moving forward. Everybody at Instacart is divided between these four general teams, including the data science team, where people are mapped to these different four sides of our org. The reason I mention that is that, again, when it comes to things like an analysis was done, an experiment perhaps was run, oftentimes what's good for one side is not good for the other. And there then needs to be some way to try and reconcile and adjudicate this situation. Many times that involves data science. More so than not, it involves communication and soft skills and the ability to persuade. And so I'll touch on that in just a second. This is a quick rundown of my experience, and many of the things that I'm talking about are Instacart specific, but they're pretty close to, there are other examples at other places I've worked at that are very similar in nature. I've been at Instacart for the last 3+ years, two of which, the first two, I led the ads data science team. And so there's a few examples that I'll hone into that are from that team that I think are interested in as we move forward. And I currently right now lead our experimentation team, which is really like a centralized team trying to expand our experimental capabilities on the platform. And so that entails a whole lot of different stuff that I'll tell you about in just a bit. When it comes to what does a director do at any of these companies, including Instacart, my role generally is to try and facilitate collaboration between my team and the other cross-functional partnership teams that exist in the company. So, for instance, or I should say, from an organizational point of view, there really is no hierarchy. So between my team, the data science team, the engineering team, and the product team, there isn't an ability of someone from my team, for example, to say, hey, this is a great idea we want to pursue. Engineering team, you must come along and help us pursue that by building this product or by engaging in some sort of work that helps facilitate us to do the cool data science that we think should be done. Instead, each of these teams have somewhat correlated, but also different objectives and views about what is the most important thing and what should be prioritized. And so the director tends to work with the other directors to try and persuade them that this particular topic and this particular area is worth their time and that they should help and collaborate when it comes to working on that particular thing. And there's a dark art to doing that when it comes to horse trading and thinking strategically and also just generally developing relationships with other folks. And so at the beginning of my career, which began in 2008, I did a lot of hands on keyboard, heads down work. In the last 5-10 years or so, I've spent much more time developing those dark arts of communication and relationship building. And so generally that's what someone in my position tends to do. Okay, what does somebody who is actually hands-on keyboard look like? So at Instacart, we hire folks who have come from either a STEM or social science background. If they're a master's degree holder, they usually have 5 years worth of experience. If they have a PhD, they usually have 3. One of the reasons why we have those limits or those requirements in place is what I kind of just alluded to a second ago. There's a whole lot of communication and a whole lot of soft skills that kind of comes with having hands-on experience working at other companies, especially interacting with non-technical folks, that pays huge dividends when it comes to getting stuff done at all the places I've worked at previously. If there's one takeaway from this whole presentation that has nothing to do with experimentation that I'd like to leave folks on the call with, it's the idea of the value of being able to persuade non-technical people why your analysis is something they should listen to and follow. That's really what separates a okay data scientist from a great data scientist, as far as my experience has shown. We are at Instacart what's called in the industry a full stack team, and basically that means we're generalists. We do everything, and so that begins with things like working with engineers on instrumentation to figure out, what events should we be logging, and thus should they, be appearing in some database someplace. And in turn, how do we take those events that are raw data and convert them into some metric that's worthy of paying attention to? So that's like sort of the beginning of the process. Everyone is heavily involved in pipelines and pipelining skills. We use quite a few different tools to get our pipelines up and running at Instacart. The reason I mention this is that when I was in school, the extent to which I was dealing with big data was pretty limited. And so as a result, that wasn't something that I ever thought about. But even calculating a mean when you have, enormous numbers of observations, trillions of observations, becomes something to sort of like rethink, how do I do that computation? And that's something that winds up getting quite factored into the pipeline design. We do not have really a substantial data engineering component at Instacart. And so a lot of that work winds up falling on the shoulders of the DSs who are needing that data to do their work. Dashboarding is obvious, and that's par for the course. Experiments are our primary tool and our primary focal point on the job. And then we also get involved in a little bit of machine learning prototyping. Where we differentiate, we do have a machine learning engineering team in the company. Where we differentiate is that team is responsible for production modeling. And so that's, depending on who you ask, it's either the cool thing to do the production modeling because you are truly the person who is controlling what the app does. If you ask someone who does not do it, they'll tell you, but you're also the person who gets the phone call at 3 o'clock in the morning when the model doesn't work. So it really depends on what side of it you prefer. But these roles are very much similar in terms of the kinds of characters that are data science candidates are also the types of characters who are machine learning engineering background candidates as well. Final thing I'll say about this, folks on our team tend to spend about 85% of their time focused on executing the product roadmap. So they're embedded with a PM as well as an engineering manager and engineers, and they have a specific set of things that they're trying to get done over the course of a period of time. About 15% of their time is dedicated to research and development, thinking ahead 2, 3, 4, however many steps ahead. And I would argue that's actually where the best stuff comes from. If it was up to me, this would be like 50-50. But that said, at 85-15, it's still such high quality and great value that comes from the 15. And this is much closer to what you would expect from academic research or something that was a little bit more longer horizon motivated. And so I mentioned that just as a sort of a sense of this is what folks are up to day to day. Tooling wise, the only thing that I'll call out here is really when it comes to SQL, not only is that sort of table stakes in order to get involved in data science, being pretty good at it to the extent that you are able to write efficient and cost-effective SQL code is huge, especially at Instacart, but also when I look at other places I've worked at, Pinterest, TikTok, really the only place where this wasn't the biggest deal in the world was Meta because they had their own data centers. That said, everyone is concerned about the database bills that they're incurring when they pay for an external party to be their data warehouse. And so the ability for you to write code that costs substantially less than somebody else, you both get the same answer, but yours is cheaper, is huge in terms of stuff that we try to promote and look for in candidates. So that's something that I'll call out. And then LLMs is the latest thing for the last couple of years that we've started to really ask folks on our team to heavily consider utilizing LLMs to facilitate doing the actual technical elements of their job. So that has to do with things like generating code, translating from one language to another, offering suggestions regarding, analytical procedures when faced with a certain situation or phenomenon, brainstorming, and then, of course, summarizing. Summarizing is just huge. Take this long thread that somebody has produced or a series of people have produced and give me the TLDR in 3 bullets. And so that's definitely familiarity with that is something we substantially look for. Okay, I will move along a little faster because I realize I'm rambling a bit here. So overview of experimentation. Speed matters a ton. The business is entirely pushing all the time for experimental results to wind up being, found and then used to make launch decisions about whether a particular feature is in fact going to be good for the business or not. The thing that I would call out, and this is true of all the companies I've worked for, causality is something that everyone understands is really the criteria by which we can make those decisions. The reason for that is that there are, in fact, folks who are doing tons of modeling and looking at correlational relationships. The thing about that is that in the end, there's such a premium on this being rigorous and buttoned up in terms of there being money at stake, user experience at stake, that folks are not willing to launch things almost ever based off of these other types of analyses. And so as a result, randomized control trials are really the go-to methodology for making all of these decisions. And so that puts data science at the heart of figuring out what it is that we should be doing. Great. In the past year, we've ran at Instacart approximately 3,500 experiments. That's small scale compared to some of the other companies I've worked at, but still quite a lot of experiments, especially given a team that is about 100 or so data scientists. What it actually means is that we've wound up expanding who actually can run experiments beyond simply data scientists to include engineers, product managers, pretty much anybody who has the ability to get into our system and do a little bit of reading in terms of instructional guidelines. We operate under a frequentist paradigm almost always. And the biggest reason for that is historical educations, experiences from other folks, in particular our cross-functional partners, about what it is and how to read an experiment. If we were to switch, and one of the things that I've been thinking quite a bit about in terms of the future, if we were to switch to an alternative paradigm, it would require quite a bit of institutional salesmanship and buy-in across the entire org. And that said, there's an interesting sort of philosophical trade-off about whether the juice is worth the squeeze for that. And I'd actually love to hear from folks about what you think in that regard when we get to the Q&A. Okay, more context on experiments. For our North Star KPIs, so our outcome variables in these experiments, we're looking at things like gross transactional value, monthly active orderers, contribution profit, and ads revenue. Guardrail metrics are also being measured. And so in each of these experiments, you're looking at more than 100 metrics are being actually taken from and logged and measured. The extent to which any one of the four sides of the marketplace winds up getting affected by a particular treatment, you'll wind up seeing that there needs to be some way of reconciling, is this worth it? And this is now really more my opinion than I think, fact, but my belief is that automatic decision making is something that we are very far from actually arriving at. What we've attempted to do, both at Instacart and at other places I've worked for, is to try and basically create what are called translation functions, which take two separate metrics and basically try to fit a curve between them to try and understand how to convert from one to the other. That said, I've rarely seen someone take the output from that curve fitting exercise and actually make decisions based off of it. Instead, what I've seen is people say, oh, great, thank you for telling me this. We still need to sit down and talk about it. So that said, maybe this will change in the future and there will be some further innovations or improvements to some of the translation functions, which themselves, are usually fairly simple OLS models. But that said, it's not there today. The only other things that I'll tell you about from context is that experiments often tend to get rolled out pretty slowly. So we're not immediately pushing all traffic into an experiment, whether that be the variant or variants and control. Rather, we're oftentimes putting a subset of users into the actual experimental experience, just so that we can get a sense of is things working as we expect? And are we, not doing something that's totally terrible for users? That creates some interesting statistical problems that come up as a result of working on a fraction of all that's available to you. And finally, one other thing that I'll point out is that almost always experiments in some form or another have a dependency from some prior experiment. And so, the launch to produce the button was a success. And now the question is, should the button be blue or green? And so there is this, in fact, inherited property that comes from previous launches and previous experiments, which makes things also something that's a little bit interesting to think about, especially when you start to think about, in total, how do you measure the effectiveness of all of the experiments, not just the lineage that I just described, but all of the experiments on the platform. So I'll get to that too. Okay, moving a little faster through this. So I'll tell you about the different types of experiments we actually run on the platform. So product experiments, very straightforward, what I've kind of been alluding to mostly. The potential savings here that are highlighted with the $2 versus the $2.99. The hypothesis here is that this will drive increased overall platform sales. So when we show people this deal for less money to buy the strawberries with, we will wind up seeing that in turn drives greater total sales on the platform for Instacart. And so maybe we should, encourage loyalty card, signups wherever we can. On the ads world, there's really two types. So similar to what I just described, you might say, well, we've rolled out a new algorithm. We've developed a new algorithm about how to rank rank ads and how to then in turn determine which ad a person should see in which slot in their feed. And we believe that this ad is better than the current, the status quo baseline model. We can do an experiment to figure that out. And in fact, that's what's going on all the time. The ads team is constantly trying to figure out if we improve by predicting that Michael will prefer to see the tomatoes as opposed to Michael will prefer to see something else, then that's actually good and better for the platform as a whole. Alternatively, we also offer to CPGs, who are largely the folks who are fueling most of the items that are available on Instacart. Those CPGs are interested in, did running ads and in turn having to incur a cost from running those ads on Instacart, did they drive more sales for their specific brand? And so that's generally in the online advertising industry referred to as a lift test. And what happens there is that a certain number of users are held back from actually seeing the ads, and thus that's how the experiment sort of is set up to begin with, at least in the most basic sense. We then do geo experiments as well. And so what we do here is we spend a lot of money, the marketing team at Instacart, on marketing the value of Instacart to the public. So the question is that if we turn off that marketing, those television commercials as an example, in certain regions throughout the country, can we use that as effectively a synthetic control in a geo experiment so that we can wind up then understanding the value of actually having it in places where we did run? And so that entails using a little bit of a causal inference as well as experimentation, but generally speaking, it is something that we do quite a bit of. Switchback experiments. So switchback experiments, generally, the hypothesis that might motivate using this is the notion of, if we changed how, for example, a shopper batched their deliveries, so what order that they got the groceries in, whether they got more than one order at a time at a particular retailer, would that lead to greater profitability as a function of faster ordering? And so one of the ways that we do that, because there's a network effect, is that we wind up engaging in using this switchback design, where we basically take a combination of the user, in this case, it's really the zone, so the zip code, if you will, the zip code crossed with time, and that creates the randomization unit that we actually use in the experiment. And the belief is, the assumption that makes this work is that there won't be some carryover effect between time by zone units when you do the change. Okay. And then the final type of experiment that we do is really a look at saying, well, all these different data scientists, all these different product managers, engineers have done a ton of different experiments over the course of the last 6, 12 months, et cetera. Can we understand what is the incremental value of the sum total of all of their work? And so, that becomes actually a tricky question, because for a variety of reasons, you start to think about interaction effects and experiments colliding with one another. You start to think about, well, how could I actually sum the experiments? And is that a reasonable approach? What we've realized is that if you have a long-term holdout, where a set of users, for example, are held back from all product innovations for the next 6 months, what winds up happening with that is that there's some positive value that comes in terms of getting a little bit of a sense of what's going on. But the negative side comes from, if you look at the diagram here, and forgetting about the various widths of the lines, if you just look at green versus blue on the bottom, well, blue had a considerably less effect on the total overall result that gets reported as far as the 6-month value that the R&D team is producing. And so that's something that actually I'll talk about in a sec. We have some ideas about how to extend that, but that's also something that we're constantly doing. Okay, a little bit of basic sort of experimentation math. So we're just to level set with everyone, we're looking to understand what is the average treatment effect. So we're using the classic, Rubin model here. We're randomizing, usually in I'll use the example of the user experiments. So we're randomizing users based on a hash function that usually has been concatenated the user ID with an experimental ID in order to create that deterministic random assignment. The goal being that there is no difference between a feature appearing or being present at some rate in the treatment or variant condition versus the control. And so that's generally the standard sort of assumptions. And similarly, we have the Sattva assumptions that come from Rubin that basically talk about no interference between units and also no hidden variations of treatments. And so nothing controversial there, but just wanted to sort of lay the foundation that we are working with the sort of standard stuff. Okay. This is the first thing that I think will actually be a surprise, or a little bit of a surprise. If you think about Cohen's d, and you think about, so the difference between two means indexed by pooled standard deviation, the question that and this table here, I remember when I was in grad school, this table was constantly showing up as a way of making sense of effects. And, in particular, I see they've expanded it a little bit to include the very small group, but generally this should be, something that folks see all the time. This is the sort of the way of making sense of and benchmarking effect sizes. The reality at Instacart is that this very small effect here that Cohen is identifying, a 0.01, is about 5 times bigger than the typical effect that we ever measure. And so a 0.2% Cohen's d, if you use sort of back of the envelope power calculation, means that you ultimately need about 4 million people in your experiment, or 4 million observations in your experiment. And so I say that because what that does is it kind of first highlights we're talking about super small effects that we're trying to measure. We are looking at those effects and trying to understand, how we can power experiments, given that, and this is no secret information, Instacart doesn't have the entire United States on the app. And so there are limits that come into play in terms of, how can we actually, given all the experiments we want to run, stay powered. And so that winds up being a serious question. And so just to give you a recap of the State of the Union, there are many experiments that are concurrently running. There, each of which has 100 plus metrics at least that we are looking at. There are usually more than 2 arms per each experiment. We're constantly interested in heterogeneous treatment effects. So that's something that's always being asked about. The effect sizes are very, very tiny, according to Cohen. And the company wants the answer yesterday. Okay, so that is the State of the Union about how it is, what a data scientist is facing, not just at Instacart, but this is true at all the big tech companies. Okay, great. So what have we actually experienced and done to try to make a little bit of this easier or better on folks? So the first thing is super simple that I actually think is that people will appreciate coming from the academic literature. So I just mentioned all of these experiments are going on, each of which has all of these statistical tests. We're using the frequentist paradigm to try and understand, is there something statistically significantly different from something else? And so you've got different arms, you've got all these different metrics, you've got all these subgroups that we're trying to understand. Does it work differently for this subgroup versus that? And so what that does is that introduces all sorts of error. Not only the false positives, but you have what Gelman talks about as, sign errors. So this is coming out negative when it should be positive and vice versa, as well as errors of magnitude. And that one is particularly nerve-wracking because if an error comes back with a tremendously positive, really great result, it's going to be very difficult to throw the brakes on that, even though everyone kind of raises their eyebrows and says, wait a minute, this might not actually be something that we can trust. And so people talk about like Twinman's law as being an example of that, where if an answer or a result comes back that's too good to be true, it probably is. And so that's being said, one of the things that we realize would be a good move is to transition from thinking about things from family-wise error to using false discovery rate. And so the easy thing that we did here is basically build out the adjusted p-values that come from using the Benjamini-Hochberg procedure, which I have here, which is basically, just taking the original p-value and scaling it up based on the combination of the number of tests that you've run, as well as the rank order of your specific p-value within those tests. And so super easy to do. And the thing that I like about it, and the reason why I'm sharing it, is not just that it's a connection to academia and something that's kind of interesting, but it highlights in general at Instacart how keeping your mind and your attention on uncertainty and error is something that as a business is a good thing, coming at things from a data science perspective. And so I'm really, I'm proud of this in the sense that I'm pretty sure there are folks who, as a result of us doing this, are now thinking about things in a way that's a little bit different than they were before. And so anyway, this is something that, as an example, folks on my team worked on. Okay, I will move to the next example. And so I mentioned earlier about these lift tests for the CPG companies. And so again, just to remind you, the idea here is this ad here for the, someone has searched for lettuce, and we've inserted an ad that is for Nature's Sweet Salad tomatoes. And the idea is that that will in turn increase sales for Nature's Sweet Salad tomatoes. And we will then compute, what was that incremental effect, and in turn get back to the people at Nature Sweet saying, okay, here's what the incremental sales were associated with this. And in turn, what was the incremental return on ad spend? Because they spent some amount of money to get those ads inserted into, in this case, whoever's feed. So that's the sort of the context behind it. The thing about these lift tests is that they wind up becoming a little bit tricky from an experimental design point of view, because there's a lot of machine learning going on underneath the hood in order to put this particular ad in this particular slot in my feed, as an example. And so what winds up being the case is that a lot of companies will fall back on using an intent to treat design. So I show that here. The idea here is, if you look at the lightest color, the outer layer of this diagram, you have a holdout and you have a treatment group who have been basically assigned to based off of hash function. And you have in the darkest color in the middle, these are the people on the left who have actually been exposed. And then on the right, you have the people who would have actually been exposed if they hadn't been in the holdout group and had the ads withheld in the first place. And so one of the things that we implemented at Instacart to try to deal with this, because aside from the fact that it becomes tricky to do this from a avoidance of selection effects, we also have a problem in terms of error, right? And so if we just think about intent to treat, all of this in the outer layer here is extra error that in turn is increasing or decreasing our power. And so that's making things harder for us to measure, and in turn slower for us to get back to folks, or just in general not being able to provide effects back to the people at the Nature Suite as fast as we would like, or as precise as we would like. And so one of the things that folks at Google came up with, it looks like 8 years ago, is this notion of ghost ads. And the idea there was, at the insertion level, can we run a simulation of the auction amongst the people in the holdout, so a separate simulation of the auction for them, so that we can figure out who would have had the ads inserted into their feed had they not been in this holdout. And so we implemented that here at Instacart. And, obviously just looking at the diagram, you can tell this isn't to scale, but it does highlight that there is in fact a benefit to doing that in terms of reducing standard errors. So that's something that we rolled out about 3 years ago or so, and has been incredibly helpful in terms of allowing us to show different advertisers, hey, this is what you're actually getting in return for your investment, and doing so in a way that's precise. What I have here in the darkest color in the inside is something that we didn't do at Instacart, but we did when I worked at Pinterest. And what this is this notion of, instead of ghost ads, here we have what folks call counterfactual logging. And so the difference between counterfactual logging and ghost ads really is this. In ghost ads, you're talking about who would have had the ad inserted. But because you're running a feed-based app, the question then comes along, well, would they have scrolled and actually viewed that inserted ad? And so counterfactual logging allows you to actually even further narrow down who winds up becoming the eligible set, because you can track through logging what somebody actually viewed in the replacement slot that that treatment ad would have been in if it wasn't that the person was in the holdout. So as an idea or a way of looking at this, here's an example for a search for drinks. And you can see that there's all these different campaigns for different types of soda and juice. And so we have the actual auction position in column 2 here, and then the simulated column position in 3. And basically what we're trying to do is understand, would the person have actually viewed this Coke ad if that, based off of what did they view instead of the Coke ad, because it wasn't there, there's something else that was replaced with it. And so there's some pretty interesting technical work that goes into figuring out how do you actually implement that, that we did at Pinterest, that involved figuring out this logging. And then, from a statistics point of view, it's an uptick in terms of precision. So good on both fronts. Lots of undertaking though. So you might wonder why, going back, why is it that some companies still stick to the ITT approach here? This is an enormous task for most engineering teams to take on in terms of figuring this out from like a simply logging point of view. And that winds up then being something that has to fit into a product roadmap. And so going back to what I said earlier, what does a director do? A director gets cozy with the engineering director and talks about all the good stuff that will come if you build this. And that's why we should spend, all these resources on getting this done. Okay. This might be a little bit interesting. This is in here as a relic of some previous presentation I did. But generally speaking, when it comes to computing standard errors, and now that we've done all this, we've shrunken it, the error as much as we can by design. One of the questions comes up is that, well, how do we compute standard errors for certain metrics, like ratios, for example, where the ratios are really small, or there's like skewed data underlying it. And generally, like, there aren't great analytical solutions to doing this. And so the two moves that people think of is they say, well, I can use delta method to figure this out, but that it requires figuring out the partials and trying to, putting all of that in. And there's some assumptions about linearity there as well. Alternatively, the move is to say, let's use some sort of resampling. The problem is, going back to what I told you earlier, we're very concerned about keeping those snowflake data warehouse budget bills low. And so the idea here is that what we've done is basically randomly assign users to 20 different groups. And those users, then we're conducting a leave one out jackknife resampling. And so that's how we've sort of gotten around that. But figuring that out, most people think of jackknife and they think of like predictive analytics and stuff. Using it in this regard is very helpful in terms of cutting costs when it comes to having millions of observations, billions of observations. And so that's the kind of thing that folks working in industry are tasked with kind of solving those kinds of problems. Okay. The last thing I want to tell you about is really some great work that folks on my team did this last 18 months or so. In particular, Tim Hesterberg and Ben Knight wrote a paper that's an archive that talks about basically this method and how we've implemented it at Instacart. That said, this method is not actually new. Our implementation is a little bit new, and also we show some of the derivations about how it works. But this notion of doing what is generally considered ANCOVA regression with pretreatment covariates, including the outcome variable, it's commonly referred to by folks, especially coming out of Microsoft, as CUPID. which I forget what that acronym stands for, but it's all the same thing. And so the idea here is that if there is in fact explained variation between an outcome and the pre-treatment data, that you can wind up then shrinking the overall standard error associated with what you really care about, which is the treatment effect. And so effectively, this is thinking of all the other covariates as nuisance controls, and basically then using this standard technique to wind up getting at what that revised or better standard error is now that you've accounted for these other factors. To show you just a little bit about this, so like on the left, you have the standard way that somebody in the most basic of experiments would do their analysis. You've got a t-test where you've got the standard error in the denominator here, versus instead we're talking about using, in our case, OLS to basically estimate what is the standard error associated with B1 hat, and using this X matrix, which includes the pre-experimental outcome variable as well, to try and understand, what's that standard error. And the big question then that comes up is like, okay, great, we're going to do this. People have been doing this for years. What's the big deal? How do you do this in SQL in terms of figuring this out? Because we got to do this for literally dozens per day of experimental runs with millions of observations, if not billions of observations in some companies. How is that going to wind up working if we have to read this into R or Python, even if we have a dev server up and running? It's not scalable. And so we need to be able to figure out a SQL approach. And so we looked into this Frisch-Wald-Lovell theorem, which was like a fun academic kind of like foray. And basically what this does is that it says if you take the predictors, you regress them on each other in all pairwise predictors, regress them all on each other, take the residuals, and then use those residuals in a scaling them up based off of the standard sort of like regression coefficient equation. You wind up being able to reproduce OLS easily via SQL. That said, why didn't we use this? There is a lot of templating that would have gone into this in terms of not every experiment has that same X matrix. And so we looked at it pretty closely, but it basically came down to fear that as the difference between the pre-treatment covariates varied from experiment to experiment based on contexts and all sorts of different questions that were coming up, we would be in a rough go to try and make this work without having all sorts of bugs and breakdowns. So instead, one other question you might be asking, why don't we just use, like, for instance, Snowflake ML cost? So what did we actually wind up doing? We downsample, we send the data into Python, we do the OLS there, we send the results back, the coefficients back, do the final computations in Snowflake in order to get our answer. And so as I said earlier, aside from the goal of trying to do this to get more precise estimates, make decisions faster, the motivation for taking this particular approach as opposed to the other two is largely savings. Ben and Tim put together a meta-analysis, which I really encourage folks to check out, which basically demonstrated that there was a 66% reduction in terms of the time it took for us to make a call about a particular product launch as a result of employing the covariate adjusted metrics versus using just the raw metrics. That's huge. And so that's the kinds of tremendous win that we were so proud of and the org was so appreciative of. And that's why this, in fact, technique is what most people are using at Instacart to try and make decisions about. I'll give you just one other little anecdote about this, which I think is kind of it makes sense as far as trying to put a little bit of dose of reality to all of this stuff. The reason why this works is because there is that strong relationship between the pre-treatment covariates and the outcome in this example. And that makes sense from like a grocery delivery point of view. What I'm buying in the past is likely going to be, roughly speaking, in terms of like the amount of money I spend, similar in the future. There's going to be, of course, differences, but it's not going to be, there will be some correlation. When I worked at Pinterest, we attempted to implement covariate adjustment and it failed miserably. It's also pretty obvious after the fact that it would. Why is that? Because Pinterest is a totally different app where it largely is encouraging people to go out and to discover new things that they've, to try. So for example, like, you're going to go on a vacation, you're going to go skydiving, you're going to go buy, wedding dresses, and you're going to create your pin boards to showcase your ideas about what you would want to do. Maybe you're going to remodel your kitchen or bathroom. Again, similar story. These are not things that you do every 2 weeks. These are not things you do every month. These are kind of one-offs. And so that correlation, when you get the sales data back from the bridal store or the Home Depot or wherever, when you wind up then looking, is there a relationship between what Michael has been buying in the last even 6 months from this place, from this retailer, versus what Michael just bought? The answer is that relationship is poor. And so that's why when we try to implement this, the covariate adjustment led to nothing like this 66% reduction. It, 2% was something like that it led to. So it really depends on the context would be my my takeaway from the whole thing. Okay. I'll round out, just taking a peek at the time here. I'll round this out pretty fast because I do want to save some time for Q&A. So what are we doing in the future? Well, one of the things I mentioned is we have a hypothesis that a lot of the product experiments that we're running are driven by novelty or primacy effects. What do I mean by that? These measurement periods tend to last 3 to 4 weeks, and we make a call, and then we have certain beliefs about the extent to which those effects persist with respect to time. One of the things that we are, I also talked to you earlier about the sort of the notion of our calendar-based measurement or long-term measurement being a little bit of a problem because we wind up having scenarios where earlier experiments count for more than newer experiments. And so one of the things that we're trying to figure out is if we extended our measurement of single experiments for, let's say, 2-3 months longer, that would give us a read on whether or not these treatment effects are decaying over time. The problem with doing that is that we would need to keep a control group going during the whole thing, which in turn would be costly from an experimental point of view or from a business point of view, which is something that the company, doesn't want to do. And so how do we figure out how to do more with less is really at the crux of this question. And so that's something that my team right now is outlining different plans for basically how can we figure that out. Oh, the other thing I was going to say is that we also are interested in, we spent a lot of time actually working with folks in academia about the idea of surrogate metrics and the notion of connecting short-term learnings from to long-term measurements that are not measurable, let's say, in a 3 to 4 week experiment, and trying to basically improve that extrapolation that folks are wanting to do. This I'll skip over. This is just a highlight of what I was talking about earlier. The other big one that we're working on is group sequential designs. And basically, this starts with the fundamental perspective that everyone is peaking at experiments early. Even though an experiment is powered to last 4 weeks, a PM is looking at the experiments 2 weeks deep and saying, hey, numbers look great. Let's call it. And so obviously we can't do that because when we start to peak, it inflates the false positive rate. And so that will then, cause problems in terms of us, launching things that shouldn't be launched. And so our plan is really to say, accept this, that this is the nature of the beast, and let's try to figure out a way to adjust accordingly. Basically what we decided is that we will adopt either the Pocock or the O'Brien-Fleming design. And so both of those are sequential designs that allow for early peaking, as long as the peaking winds up being planned. What we ruled out, which has had a lot of positive discussion and talk in the industry data science community, is the always valid p-values. Several companies have adopted that. The reason why we ruled that out is because we generally realize that we don't actually need to always be looking and always peaking. That's probably overkill for what our use is. The other side of it is the price you pay for having those always valid p-values is that it's pretty conservative in terms of power. So we ruled that out. But we're still weighing in whether the Pocock model has the constant alpha, whereas the O'Brien-Fleming one has it increasing. And so that will be something that we'll try to figure out in the next few months. But that will satiate this issue of inflating the false positive rate. And then the final thing I'll mention is this. I know I've entirely talked about frequentist approaches to experimentation and even just analysis in general. One of the strong pushes internally that our top individual contributors have raised is the idea of becoming more Bayesian, adopting more techniques from reinforcement learning, like, for example, multi-arm bandits, conditional bandits. We have manifestations of that on our platform, and actually occasionally incorporate that in terms of like how people will approach different problems. It is not, though, by any means the fundamental way that people make sense of things at Instacart. And when I think about personally, like my own agenda, there's an enormous amount of work that goes into transitioning from that frequentist view to an alternative view. And so if we were to do that, what would it take, and what kind of education would be required? What kind of hand-holding would be required when it comes to doing all of these experiments? How would we make sure that the business was still running and that this didn't grind things to a halt? And so the other thing that I would just sort of add is the introduction of priors, which is something that would come with, for example, a Bayesian point of view, I think has tremendous positives on one hand, but the final point that I throw out here is, does this enable too much incrementalism? If we wind up having priors that allow us to get away with doing more with less, or alternatively estimating very smaller effect sizes, is that something that we shouldn't encourage or enable product teams? And what I mean by that is, one of the main goals of, I would argue, of being a good industry data scientist is pushing product partners to come up with good hypotheses and things that will actually move the needle for the business in a substantial way. If we fall into a pattern where we keep coming up with new techniques that will make smaller things easier and easier to measure, that may be great from like a immediacy point of view. We've solved the problem that was at hand, but should that be the problem that we're actually solving in the first place? And so anyway, I'll leave you with that. That's kind of like my philosophical question about the whole thing. But this is what is on our agenda for the next year or so. And with that, I will close out. I realize I may have gone a touch right at the nose. I'm happy to stay later though and answer any questions. And please take down my email if you'd like to chat separately. I'm absolutely happy to do that.
Well, thank you. That was incredible. And I think you gave such a great sort of primer on all the tools that are being used. And it's interesting because I think that Gen AI and LLMs are so prominently out there in the public imagination right now, and you're really sharing really fundamental causal inference methodologies that are really driving business decision making still at a major company. So that's really interesting in terms of point of view. I'm going to use host prerogative to ask a question. And this actually combines some of the questions that I saw coming through the Q&A. When you're thinking about, you do have a four-sided marketplace, you are sort of making decisions for, four different groups of users. Who is making those trade-off decisions? How do you think about communications with leadership, especially in terms of the tools that you're using to decide, whether something is a benefit to one side of the marketplace or not? How do you think about making those decisions and I guess, advocating for trade-offs?
It's a great question. There's no simple answer to it. We've attempted to come up with a simple answer to some extent by implementing some kind of technical approach where we say, okay, well, look, here's what all of the positives and negatives are associated with this idea. Let's try and, mathematically back into what we think the solution is. That generally doesn't seem to have landed almost ever. Especially in situations when we're talking about something that's like high priority or something that's very interesting potentially for the business, it really mandates coming at it from a conversational point of view. And so I realize this isn't like a satisfying answer, but I think like what I would recommend to anybody who is even remotely considering working in industry or working with folks who are in industry is that the ability to sit down with everyone in the room, articulate what's going on, be understood, and generally, have a rapport with others, that actually goes way further than any of the sort of technical, mappings that we can do between metrics and so forth. And so when folks are first coming out of school, one of the things that I'll advise them is, it's great that you've learned all of the latest new technologies and tooling and everything else, but you also need to really learn how to talk with others and collaborate and persuade and do a presentation and all of that sort of thing. It really goes a long way.
That's terrific. And then one more question. And I'm so sorry, there are great questions in the Q&A, but I think we'll stick to one more for the time being. How do you consider the potential role and benefit of AI tools in your experimentation methodology? Same question with your business and operating models. How do you think about evaluating those?
We've spent a ton of time thinking about this question, and we have an internal version of a ChatGPT that is Instacart specific and tuned to our specific data and everything else, trained to our situation. I think relative to other companies out there, we actually are at the forefront in industry of adopting this. Everyone, whether it's a data scientist, engineer, product manager, is utilizing, I say everyone loosely, 95% of the company is utilizing LLMs in some form or another to improve their workflows. In the experimental domain, where that largely manifests is two ways. One is in terms of helping to generate SQL, and the other way is in terms of trying to get a sense of meta-analysis. So we've got all these experiments going on. We've got all this output that's sitting around in the cloud with this is what happened with each one of these metrics. Can we wind up taking that output and providing some cursory understanding of hey, we've already measured this hypothesis many times. Here's what the results came back looking like. Here's some summary statistics even based off of it. And so that's largely where it fits in on the experimental side. But in general, everyone is doing this and is being goaled kind of also about, are you doing it, from a company OKR point of view?
I heard someone recently say, if your company hasn't had AI at its center yet, you're too late to implement an AI strategy. Meaning, do you really actually need it? It's an interesting perspective. Okay, so final question, which is going to be, what do you recommend as a fundamental paper that everyone should read out there?
Oh, so firstly, I would be remiss and also disloyal if I didn't promote Ben Knight and Tim Hesterberg's paper that I was mentioning earlier in the presentation. I really think that that's something that would be an interesting look for folks. When I think about actually what might be a good read, I have this right in front of me, coincidentally. This book, which I will try to get out of the blur. Can I
You can tell me the title. We'll put it in.
tell you the title of it. Ronnie Kohavi, Diane Tang, and Yazoo put together Trustworthy Online Controlled Experiments, which is a practical guide to A/B testing. This book basically is a synthesis of everything the industry knows about A/B testing, all of the potential pitfalls, problems, things to look out for. And it's essentially required reading if you are interested in running online experiments at large companies where they have a lot of observations, users, et cetera. And even though it's not a journal article, there are certainly rigorous components to this. So it's worth taking a look and buying, checking out, what have you.
All right. Well, thank you. Thank you so much for your time. Thank you for this amazing presentation. Thank you to all our participants and your really great questions. Before we close, I'd like to mention that our next industry seminar will be on October 3rd at 1:30 p.m. with Maria Bowman from the Department of Agriculture, the USDA. Registration's available on our website, datascience.harvard.edu, and through our weekly newsletter. We hope to see you there. So with that, I'm going to close out the afternoon. Thanks once again, Michael. Really appreciate your insights, and stay in touch.
Yeah, likewise. Thank
All
you.
right. Take care, everyone.
Bye.